Hello, welcome back guys and welcome sa subject natin for today, AS 101, Theory of Structures, and this will be our first lecture session on this subject. And for today's lesson, we will be tackling about introduction of structural analysis or theory of structures and what are the loads that you need to be aware of when calculating for the forces you need for our beams. Okay. So here are our lesson outline and learning outcomes for this session. Outline of our lessons are first, introduction to structural analysis, then what is the role of structural analysis in the whole project, okay? Then we have to classify our structures, and then we also need to identify what are the different loads present, especially here in the condition of the Philippines, and we have to solve examples in calculating these loads. Okay, so at the end of the session, here are the things that hopefully you will be able to learn. First one is to be able to explain what is structural analysis and why it is important. Second is to outline to you the different classes of structures, differentiate them with each other, then to describe the different loadings that may be subjected to the structure. And last is how to calculate this loadings based from a given condition. Okay, so let's start. So as introduction, so we have to first define what is a structure. So a structure now refers to a system of connected parts used to support a load. So definitely very familiar na tayo dito na what are the some of the most important examples of structures that we observe in our life, no? So we have buildings, of course, then bridges, towers, um, we have also yung mga ship and aircraft frames natin, tanks, pressure vessels, power plants, in industrial parks, no? And etc. So when designing these structures, uh, our aim is to serve a particular function. Especially you guys, as future architects, kayo yung nagpo-plan, is the structure that we are designing accessible for the occupants of the said structure? Is it following the minimum standards of the code? No? Then, while taking into consideration yung mga bagay na to, we also need to focus on economy tsaka yung mga environmental constraints natin should be accounted. Okay? So once yung preliminary design ng structure natin is proposed, the structure now will be analyzed by a civil engineer to ensure that your structure or the design structure that you prepared has the required stiffness and strength, no, to withstand yung mga possible forces na ma-apply sa kanya. And when we say stiffness, it is yung inability ng structure natin to move, no? So dapat hindi siya madaling malipad ng hangin. Okay? Dapat hindi siya madaling masira pa nag-sway siya during earthquake or seismic activity. And then strength, syempre kailangan natin may capacity yung structure natin to carry great forces or pressure from external loadings. And also its own weight. Okay? So once these things are achieved, we can proceed with the um, construction of our project. Structural analysis is also defined as the prediction of the performance of a given structure under a prescribed loading. It's also concern other external effects such as the movement of the support and also changes in the temperature. So yung performance characteristic commonly of interest ng designer, ng structural designer in general, is the calculation of the following values, yung stresses na ma-apply sa structure, yung deflection na pwede nyo ma-experience, and what are the different support reactions na kailangan nating i-calculate. Okay? So pag sinabi nating stresses, di ba, yun yung quantity na nagde-describe sa magnitude ng force na nagko-cause ng deformation. So ano yung value na yun? Ano yung value ng force na yun na nagko-cause ng deformation o ng failure dun sa mismong structure natin. Then when we say deflection, the deflection is yung pag-change ng shape ng ah, object natin, ng material natin, or for our case, yung beam natin, when it is applied or when it is applied with a load, no? So what will be its behavior? And then lastly, yung support reaction natin is ito yung force na ine-exert dun sa supporting element, dun sa mismong member na dinedesign natin. So, say for example, yung from the beam, so si beam, ito-transfer niya kay column yung forces niya. So, kung gusto natin i-simplify yung design, what would be the forces at the ends of the beam that will be transferred or carried by the columns so that it will be transferred dun sa foundation natin. So, um, ilan lang yan sa mahalagang interest ng theory of structures kung bakit natin siya kailangan gawin sa structure natin. Then the analysis of a structure usually involves determination of these quantities na dependent sa given loading condition natin. So, a glimpse lang, although hindi naman tayo structural designer, I would like to present also what is the flowchart being done when we are doing structural analysis or uh, or undertaking yung theory of structures natin. So, structural engineering is the science and art of planning, designing, and constructing safe economical structures that will serve the intended purpose. Okay? So, yung pinaka-goal talaga ni structural analysis is to ensure that our building is capable of withstanding and having the right stiffness and strength to serve its purpose, no? So, here is a sample flow chart na nangyayari in the industry kung saan papasok yung theory of structures o yung structural analysis na tinatawag natin. So first we have yung planning phase. So sa planning phase, syempre mas involved or mas concerned dito kayo as architects. So kayo talaga yung nagde-describe nung nagpa-plan out nung magiging um, layout nung mismong structure natin. So, the minimum spaces required and then kung ano yung gusto ni client, kayo yung nagko-consider nun. Then, right after you finish planning or meron tayong proposed structure, so, dyan papasok si preliminary structural design. So, di ba, kayo as architects, you are entitled also to have assumptions ng mga sizes nung structural elements natin. Pero pagdating kay structural engineer, there are some cases kapag halimbawa medyo iba yung na-declare na size ni architects, after analysis, na babago yung size natin. Kaya minsan, kailangan ng constant communication with the engineer and then the architects para alam natin kung halimbawa kung yung framing plan ba natin is okay na. Pwede ba tayong magdagdag ng column kasi sa tingin halimbawa ni engineer is medyo critical yung area na to pero kailangan ninyo na malaki yung space kaya ayaw yung na may column dun sa area na yon o kaya halimbawa gusto niyo naka-flash yung ating mga columns, no? Pero kailangan halimbawa suggestion ni engineer kailangan talagang medyo lalakihan natin yung depth, no? Para kaya pag na-construct siya, may nosing tayo ng mismong column natin. So, dito pumapasok sa preliminary structural design. Ang gawain naman ni structural designer, mag-assume din siya ng initial sizes na based from previous experience niya. And then, from practice na din. Then, from there, kung meron na tayong sizes, we can now estimate yung loads na pwedeng mag-carry yung structure. So, kung yung structure itself yung pag-uusapan, ang una-una natin i-identify is yung kanyang dead load, yung own weight niya. And also, lahat ng mga future na pwede nating ikarga sa kanya. And we will have also yung live load na later i-discuss naman natin all throughout. And then, i-assume din natin ngayon yung mga other loads na pwedeng tumama sa kanya. Like for example, kung medyo mataas yung structure natin, definitely it will be more prone to wind loads, no? Especially kung halimbawa yung area is very low terrain yung mga kalapit niya or wala masyadong puno, walang mga harang. So, since ang wind natin is continuously moving, magiging obstruction yung structure natin na mangyayari siya yung sasalo ng wind force na manggagaling sa external load, no? Then we also have yung seismic load natin during earthquake na requirement is kapag more than 3-story na yung or more than 2-story na yung structure natin, required na talaga na may structural analysis. That is for residential structure. Pero pag dating sa mga commercial, dapat talaga may seismic pa din kahit anong size na. Okay? So after nun, may loads na tayo. Yan, dyan na papasok sa structural analysis. So yung sa subject natin, we will not focus on this calculating all the forces na kakargahin niya from top to bottom, no? Halimbawa, from the roofing itself, then paano siya na-transfer sa mga kasunod na member niya, like halimbawa sa mga girder, sa secondary beam natin, then sa column, sa foundation, so sa slab, kung paano na-transfer yun, hindi natin concern. Ang concern natin is C-beam. So C-beam, meron siyang kinakarga na tributary section or area. So yun yung magiging focus natin for the subject. Then once we perform the structural analysis, ma-identify ng engineer ngayon kung yung assumed sizes natin from the second step are feasible or pwede siyang tanggapin, i-accept dito, no? So yun yung mangyayari ngayon. Once na sabihin natin hindi safe pa din yung mismong dimensions natin, kaya kailangan natin mas stiffer yung building. So maglalagay tayo ng shear wall. Okay? So, nangyari, revise tayo ng structural design. So, based from that, adjust natin yung dimension, dagdag tayo ng structural element, which is yung shear wall, and then estimate ulit natin yung bagong load niya. Kasi nga, nag-adjust tayo ng mga weights. O nadagdagan tayo ng dimension, nagdagdag ng depth, or yung thickness, pinapala natin. So, mababago siyempre yung load natin. And then, same procedure na structural analysis and then checking ulit based from the requirement ng code ni engineer. And then, once na pumasa na siya, so, syempre ito, medyo shortcut na construction phase na agad. Pero after na, syempre, madami pang usap na mangyayari. Meron pa din si cost, and then drawings pa before pa mag-issue for construction na drawing. Pero eventually, once everything is settled and every professionals in the project are all okay na ang status, definitely construction will initialize na. Okay? So that is just a glimpse kung paano pumapasok si structural analysis dun sa mismo project natin when we focus on actual conditions na. Okay? Then we now go dun sa classification of structures natin. So sa structures, recognition of the various types of elements composing a structure is important para kay designer. Kasi kung hindi niya alam yung tawag dun sa mga structural component na yan, parang ang hirap i-analyze, no? Kung halimbawa nag-uusap tayo technically, tapos pag sinabi kong biga, tapos yung kausap mo hindi pala alam kung ano yung biga, so mahirap kung hindi tayo nagkakaintindihan. So it is very important that the designers or professionals, engineers and architects are very knowledgeable dun sa components ng structure natin. And some of the structural elements natin are tie rods, beams, and columns. So as you can see here, yung tie rod natin, ito. So si tie rod is a structural member na subjected to a tensile force. Kung makikita nyo, sabihin lagi siyang, usually lagi siyang binabanat. Okay? So kaya tie rods o mga sa mga bracing strap, no? Yung ginagamit. So sa natin to na ano, sa mga secondary structure natin, medyo ginagamit din natin. Bawa sa ceiling, no? Ginagamit natin. Pwede din yung mga yan yung mga angle bars natin o channel natin, mga yung mga paring natin, no? So yan yung sample ng tie rods. And then we have yung beams. So, ito yung magiging concern natin for the rest of the semester. Beams na dependence or nag-iiba-iba ang ang kanyang performance depending sa support condition niya. We have yung simply supported, cantilever, fixed supported, and then continuous beam. Okay? So, later ma-identify naman natin yan kung paano siya nag-iiba-iba. Pero halimbawa na lang si cantilever beam, kasama natin makikita si cantilever beam. Halimbawa, meron tayong terrace, no? So, cantilever beam yan. Kasi from dun sa mismong column mo ng framing mo, yung naka-overhang mo, syempre kailangan suportahan niya. So, may certain length lang siyang kayang suportahan. Kung halimbawa, konkreto yung gagamitin mo, usually, more than 1.5 meters is not okay kapag overhanging siya. Kaya nangyayari, kung makikita ninyo, although minsan dito nagkakamera ng discussion si architect at si engineer na pagkabawang naging 2 meters na siya, usually ang request sa engineer, lagyan ng column sa ilalim. Kaya ngayon si architect, minsan hindi po payag na meron doon kasi nga, ano yun terrace yun, ba't lalagyan mo ng column? So, nangyayari, ibabawasan ng konti or ang mangyayari, kakapal yung depth. Okay? So, depende sa agreement ng engineer at architect yung nangyayari doon. Okay? Then we have yung columns natin or yung mga vertical element natin sa framing natin, sa structure natin. So, like this one. So, yung mga naka-drawing are steel members, no? Pero we have also reinforced concrete, we have timber or yung wood, okay? Then yung isang nauuso na ngayon or emerging technology is yung ating structural bamboo. Okay? Next. We also have different types of structures, namely trusses, cable and arches, frames, and surface structures. Okay? So, ano yung differences niya? So, kay trusses, so halimbawa, ang gusto natin is yung spanning natin is large, pero yung depth natin is not a major concern. Usually, si trusses yung ginagamit natin as the structure needed. So, ganyan yung nangyayari sa mga bridges natin. Kaya usually, pag hindi um, trust yung itsura ng beam natin, minsan ibang klase ng beam yung ginagamit. Pero si trusses are more applied sa bridges and of course sa roofing natin. Okay? So, ang main loading kay trusses are axial forces. So, pag sinabing axial forces, mga tension and compression forces lang doon sa mismong member niya. So, yung member niya mismo to, yung loading niya is along lang doon sa kanyang length. Okay? And then we have cable and arches. So, si cables, okay, are flexible na mga uh, wires, no? Sa cable. So, makikita niyo dito kung sa maliit na to. So, kinikarry nila are tensile loads. Okay? And then yung si arches are rigid and yung strength niya is very strong. So, yung compressive naman yung kanya. Okay? So, tensile sa cable, compressive yung arches natin. Then we have yung para sa framing natin. So, you can see here, meron tayong moment frame. Ito. So, yung frame natin is composed of beams and columns. And then, mainly, ang sinusupport niya are bending forces. Okay? Then, last is yung mga surface structures natin. Na ang surface structures natin are very flexible and very small thickness na members na usually sila yung mga thin plates or shells ang tawag natin. Okay? Next, we now discuss yung loads. Okay? So what are these? So design loading for a structure is often specified in codes. Okay? There are two general types of codes being used. We have yung tinatawag natin General Building Code. Na for our case, dito sa Philippines, we have the National Building Code of the Philippines. And then we have the design code na ginagamit naman namin is yung National Structural Code of the Philippines. No? I'm not aware if kung may sariling code reference si architect beside NBC. Okay? Pero yung structural loadings, pero since majority of the structure are being analyzed by a civil engineer, they are referring dito sa unit weights na nandito sa National Structural Code of the Philippines. Okay? So ano muna yung pagkakaiba ng dalawa? Si General Building Code, nag-specify siya ng requirements of governmental bodies for minimum design loads. Okay? And minimum standard for construction. Ngayon sa design code, mas detailed yung kanyang specification, yung technical standard niya. And ginagamit siya to establish yung requirement for the actual structural design. So kung dito, pag nakabuklat kayo nitong NSCP, is makikita nyo dito kung ano yung minimum requirement na bakal para sa concrete, no? Para ilang ano yung area na minimum, okay? Ano yung minimum spaces ng bakal, gaano kakapal yung concrete cover, no? Kasi 'di ba bukod sa plastering, hindi dapat nasa edge yung bakal. So, mga ganong cases. So, yung mga more technical na requirements are being tackled here in the design codes or in National Structural Code of the Philippines. And then for the requirement of the government, um, and yung requirement, minimum standard for construction are all stipulated here in the National Building Code of the Philippines or yung natawag nating building code. Okay? Next. Yan, punta na tayo sa loads. Okay? So this is almost the last part ng discussion natin today. The loads that act on common civil engineering structures can be grouped according to their nature and sourced into three classes. So yung classes na yun are dead loads, live loads, and environmental loads. So these loads are described in the codes and usually based on past experiences and study and minimum for which the various type of structures must be designed. Okay? So, isa-isahin natin yan. So, si dead load, syempre, usually, since dead load na siya, dead, hindi siya gumagalaw or permanent na siya sa structure niya. Then we have yung live load, ito yung mga movable objects natin or tayo as human beings, live load tayo sa structure kapag nandun tayo. Ibig sabihin, ito yung mga loads na hindi masyadong nagtatagal dun sa life ng structure. So, and then we have yung environmental loads. So, these are caused by the environment. So, such as wind, tsaka earthquakes natin. Okay? So, let us first start dun sa dead load. Okay? So, we have yung dead load. So, dead loads are gravity loads of constant magnitude and fixed positions that act permanently on the structure. So, nung tinayo yung structure, present na siya doon. Okay? So, sabihin, ito yung konkreto natin. Okay? Ito yung biga, yung column natin. And then, yung mga additional attachment natin, halimbawa, yung mga for aesthetic purposes natin, yung mga facade, mga windows. Okay? So, yan. Dyan kasama yon. And then, the weight of the structure is not known in advance of design and is usually assumed based on past experiences. So, dito papasok yung preliminary structural design, as I mentioned earlier. After the structure has been analyzed and the member sizes determined, the actual weight is computed by using the member sizes and the unit weight of materials. Okay? So, ayun. Hence, for a building, yung dead load natin, usually included yung weight nga ng columns, ng beams, ng girder, ng floor slab, ng roofing, ng walls, windows, yung mga plumbing connect yung mga plumbing natin, mga fixtures. And then we have electrical fixtures, mechanical fixtures, and other miscellaneous attachment na lalagay natin doon sa mismong structure natin. Okay? And here are a sample table ng mga minimum loads na ginagamit sa practice. Okay? So, minsan, para makuha natin yung estimate ng load, dito tayo nagre-refer kung depende sa structure, no? Para magkameron tayo ng weight sa pag-analyze, no? Sa structural analysis. Ito yung mga example na yan. So, yung table 1-2, density siya for materials. Kung makikita ninyo, may iba't ibang klase ng materials. We have for aluminum, for concrete, for clay, for sand, etc. And we have here dito minimum design load depending doon sa gamit niya. Bawa ito for walls, gumagamit sila ng brick, no? Pero usually sa atin, ang walls are made up of CHB, okay? Or pagbuo siya, concrete siya. So, yung mga shear wall natin. Then we have yung mga partition walls natin. So, kasama na doon yung mga framing natin. Okay? And yung mga plaster walls natin, mga uh, ano bang tawag doon? Yung ginagamit natin pang cover doon sa frame natin. Okay? And then we have floor fill. So, ibig sabihin yung ginagamit natin for slab, then for ceiling. Okay? So, yun lang yung example niya, pero when you check yung NBC and si NSCP, there is a separate table for that. Okay? So, minsan hindi to binibigay ng supplier. Okay? Kasi sa supplier, ang alam lang niya, gawa ito halimbawa sa konkreto. And tayo, as magko-compute ng loading, dapat alam natin kumuha ng volume, yung area niya, no? Then multiply lang natin with this corresponding values na nandito sa table na to. Okay? So to appreciate more kung paano ginagamit ng table na to, I prepared one example for you guys to witness kung paano siya sinosolve, no? So let's say we have here a floor beam. Okay? Ito yung floor beam daw natin. Ito. Okay? Shown is used to support a 6 feet width of a lightweight plain concrete, a plain concrete slab having a thickness of 4 inches. The slab serves as a portion of the ceiling for the floor below, and therefore its bottom is coated with plaster. Okay? Furthermore, an 8 feet high, 12-inch thick, lightweight solid concrete block wall is directly over the top flanges of the beam. So directly upward on the top of the flanges of the beam. So ito yon. Determine the loading on the beam measured per foot of length of the beam. Okay? So ito yung three-dimensional na itsura niya. So let's try to calculate kung ano yung magiging loading ng beam natin. So si beam natin is ito, we have a steel beam, no? High section siya. So ang assumption natin, kung isipin natin, without assuming kung ano yung support reaction natin, no? Dapat yung beam natin, yan, sabihin natin ito yung beam na yun. Okay? So, looking dito na ako sa ano niya, sa elevation na tayo. Okay? So, sa elevation, ito yung itsura niya, no? Okay, sorry for my drawing. Okay? And then pinapahanap sa atin is kung ilan yung loading. Kung ano yung value ng loading na nasa taas niya. Kung makita nyo sa ibabaw niya, meron tayong slab, meron tayong block ng wall. So kapag isinam natin siya, dapat makuha natin yung total na load na kine-carry niya. Okay? So ito yung pinapahanap sa atin. This one, yung red. Okay? So paano natin ko consider yan? So let's consider yung cross section niya. So punta tayo dito sa harap na. So, cross-section natin. So, halimbawa, ito yung I-beam natin. So, again, please excuse my drawing. Okay. So, yan yung uh, uh, beam natin. And then, meron daw siyang slab sa ibabaw niya. Okay. Meron siyang slab na ang kanyang width is 6.0 feet. Okay. And then, dun sa ilalim ng slab, since it is a ceiling, portion of a ceiling, meron daw siyang plaster. So si plaster, lagay ko na lang, kunyari dito na lang. No? Ayan si plaster. Okay? Although dapat dun sa ilalim pa yon. So for simplicity na lang. So sabi ito is 4 inches. Okay? And then directly above nitong flange natin, yung flange ibig sabihin yung top ng beam. Okay? So directly above it, so sabihin natin ito yung center line nun, is meron tayong wall. Okay? So not to scale na lang po ito. Okay? Ayan. And yung wall natin na 8.0 feet. Okay? Then yung width down nito is 12 inches or 1 foot. Okay? Ayan. So question ngayon now is what is this particular load? Okay? Itong load na to. Ano yung value niya? Okay? So kailangan i-calculate natin siya isa-isa. So isulat lang natin yung kailangan natin. So first, ang meron tayong nasa ibabaw, pinakaibabaw nung mismong beam natin is si slab. Okay? So we have a concrete slab. Okay? Ang characteristic ng concrete slab natin ay siya ay lightweight or plain. Okay? Or lightweight plain. Sabi naman dito, lightweight plain concrete slab. Okay? So, yan yung una natin. Then we also have another one na pagkatapos ng slab, sa ilalim ng slab meron siyang plaster. Okay? Ito yung kasunod nating weight. And then, yung nasa ibabaw ng slab, meron tayong concrete block wall. No? Okay? Yung ano niya is lightweight din siya. Okay? So, yan yung kailangan nating lagyan ng loading. Ngayon, since meron na tayo niyan, okay, check natin yung table kung saan ano yung makukuha nating values. Okay? So, for concrete slab, lightweight plain. Okay? So, balik tayo dito. Hanap ka, tingnan mo sa slab tayo. So, sa slab is floor fill siya. Okay? Then makikita nyo meron dito lightweight concrete plain per inch. No? Per inch, 8 PSF. So, si PSF equal siya sa pound per square feet. Okay? So, ibig sabihin, ito yung gagamitin nating load niya. So, ang unit niya is 8 pound per square foot per inch. Kasi may nakalagay na per inch yung value na yon. Okay? So, lagay natin dito. So, try ko lang i-adjust yung iba para dun lang tayo directly sa ilalim niya. Okay? And then, ito is adjust ko lang din. Okay? So, mula doon, yung nakuha nating weight niya is, ilan nga? 8 pounds per square feet per inch. Okay? So, yan yung nakuha natin. Kay plaster, balik tayo ulit. So, si plaster is hindi naka-indicate ko anong klaseng plastering siya. Pero dito sa ceiling natin, may plaster on tile or concrete tayo, which is 5 PSF. Okay? So, lagyan ko din to ng marking. Okay? 5 PSF siya. So, yan yung para sa plaster natin. So, we have 5 pound per feet square. Okay? Then last is yung concrete block wall natin. So, punta tayo dito sa table ulit. Yung sa wall is meron siya is for brick lang. Okay? And then for partition and wall, so wala dito. So, pupunta tayo dito ngayon sa minimum densities natin. And nakalagay dito, meron dito masonry, lightweight solid concrete. Okay? So, since wall yun, so masonry tayo. So, 105 pound per foot cube. Okay? So, ito yung gagamitin natin. Okay? So, 105 and yung unit niya is foot cube. Ang kailangan nating weight in total is ah, per foot length, no? Per foot length. So, kailangan pound per foot yung value natin. So, kailangan yung mga nakalagay natin dito, i-multiply natin siya by the area na perpendicular dun sa mismong loading natin. 'Di ba ang loading na kailangan natin, yung this loading is actually this loading kapag dito sa side na to. Okay? So yan yung kina-calculate natin. So para makuha natin yung side na yan, kailangan yung naka-perpendicular sa kanya. So kung ayan, kung ito yung loading na natin, yung perpendicular niyang sizes or dimensions is yung nandito sa along dito sa ayan. Yan yung perpendicular niya. So pag tumingin ka sa taas, um, ah, ito yung loading na yon, okay? So yung naka-perpendicular sa kanya. Kaya ito yung itong side na to is this one, and then itong to ay ito. So naka-perpendicular, ibig sabihin naka 90 degrees sa kanya. Okay? So yun yung kailangan natin. So for concrete slab, may pound per foot squared per inch. So may per inch na thickness siya. So kailangan yung 4.0 na thickness natin, multiply natin. And then ano yung multiply natin kasunod? So puntahan natin tong diagram natin, we have 6 feet, no? So pag inano natin tong naka-perpendicular niya, ang lalabas na load niya is nakaganto na. Okay? So 4 inch times yung 6 feet. Okay? Titingnan ninyo, magka-cancel yung inch, yung feet na isa, magka-cancel. So matitira is pound per feet. Yun yung kailangan natin. So calculating lang this one, talk sa calcu. 8 times 4 times 6, we have 192 pound per feet, per foot. Okay? So next is yung cluster natin, pound per foot square na siya. So dapat isang dimension lang para maging per foot lang siya. Okay? Multiply natin ng 6 feet din kasi same siya ng width ng mismong slab natin. Okay? So 6.0 feet. So, ayan. So 5 times 6 is 30 pound per feet. Okay? Then last is yung sa concrete block natin. So since may dimension tayong given dito, no? 8 feet, then 12 inch. 12 inch is equal to 1 foot. Okay? So since feet cube to, kailangan dalawang dimension na kailangan natin. So yung area, yung face area na lang mismo nung concrete natin. So meron tayong 8 feet times 1 foot. Okay? So magka-cancel yung dalawa. Yeah. So matitira 105 times 8. Okay? Times 1. So 840 pound per feet. So pag yung hinahanap sa atin is yung total loading. So total loading natin will be equals to 192 plus 30 plus 840. So yung total loading natin will be equal to 30 plus 840. That is 1,062 pound per feet, or convert natin ang 1,000 pound equals yan sa 1 kip. Okay? So pwede siyang tawagin na 1.062 kip per foot. So this will be our final answer for this particular example. Okay? So ganyan po kina-calculate yung loading natin for dead load. Right? So okay, next. Right. So next is punta tayo sa live load. So si live load naman daw are loads of varying magnitudes and or positions caused by the use of the structure. Okay? So varying, so ibig sabihin hindi siya permanent dun sa location na niya or moving siya, kaya varying magnitude siya. Then live loads can vary both in their magnitude and location. They may be caused by the weights of the object that are temporarily placed on the structure. It can be moving vehicles, kung halimbawa sa bridges, no? Kaya kung sa warehouses, yung mga ano natin, equipment natin, yung mga forklift, no? And then natural forces. Okay? Live loads can be subjected as follows. It can be on building loads, highway bridge loads, or railroad bridge loads. Okay? So sa highway is yung mga wheel load natin ng truck, ng car, okay? Yung mga um, ibang iba pang moving vehicle na pwedeng dumaan sa bridges. Sa railroad bridges naman, edi syempre yung ating mga trains, yung weight nung mismong wheel niya, yun yung ina-analyze, no? So, hindi naman natin concern masyado yon. Sometimes the term live load is used to refer sa all loads doon sa structure natin that are not dead. Minsan including yung mga environmental loads natin. However, since the probability of occurrence ng environmental load natin are different from live loads, the use of the term live load is now used to refer only to those variable loads caused by the use of the structure. So kapag habang ginagamit lang yung structure and then moving yung load, tsaka lang siya nagiging live load. Then classify the environmental load as a different kinds of load. Okay. Next, the floors of a building are assumed to be subjected to a uniform live loads, which depend on the purpose for which the building is designed. So, meron na agad tayong parang assumed loads kapag depende sa use ng building. So, we are designing for an office building, meron siyang sample na weight o yung area, certain area doon sa building na meron siyang assumed live load. Kasi kung office building yun, alam natin na meron siyang mga empleyado na nag-oopisina. So, ito yung assumed weight niya for its design life, no? Again, these loads are just minimum. So kung overcrowded yung tao dun sa mismong uh, building natin, so sabihin natin parang siniksik mo sila as pinaksiksikan mo sila na medyo violating na yung spaces sa code natin, doon magiging dehado tayo sa design kasi itong loads na nakalagay dito are of minimum quantity. So, in addition to uniform loads, some codes specify also minimum concentrated live loads caused by handcars, automobiles, and etc. Depende sa purpose ng structure ninyo, which must also be applied anywhere to the floor system. So, itong mga uniform live loads natin are generally tabulated sa code, like this one. And these values are determined from history lagi, no? From past experiences ng various buildings natin. Okay? Connecting pa din sa live loads. So for some type of building, having very large floor areas, many codes will allow a reduction in uniform live load. Kasi nga, hindi naman all the time ma-occupy yung buong space. Kaya so baka naman ma-over assume tayo ng load kapag sobra-sobra yung assumption natin ng load dun sa table. Okay? Since it is unlikely that the prescribed live load will occur simultaneously throughout the entire structure at any one time, ina-allow ng code na i-reduce natin yung uniform live load natin. And remember, having an influence area, yung influence area natin defined as KLL times 80. Yung KLL is defined as live load element factor na for interior column siya ay 4 times 80 o yung 80 is yung arbitrary area nung mismong column natin. If that exceeds 400 square feet or 37.2 square meter, pwede tayong mag-reduce ng live load. Okay? So yung pag-reduce ng live load, gagamitin mo yung formula na to, na given. So we have two formulas. We have yung FPS o foot-pound second units o yung English system natin. And we have SI units or meaning yung metric na units natin. Okay? So explain ko lang yung formula. So we have L is equals to L sub O. Yung L sub O natin, galing yan dito sa table natin. Okay? And then we have yung KL, which is again 4 for interior building. So, bakit interior yung kino-consider? Kasi kung i-ano natin, compare natin na external na column tsaka interior na column, mas malaki yung kina-carry na load ni interior kasi mas malawak yung tributary area niya. Unlike kay external o yung mga nasa dulo ng frame natin, half lang yung nakikarry niya nang compared nung kay interior column. Pero depende pa din sa configuration ng framing natin. So some cases, depende sa purpose ng structure mo, syempre, mag-iiba yung case nun. So, there will be a different value for KLL. Okay? Pero for standard structures, laging si interior column yung mas malaki. Okay? And then, I have a note lang here na when we're reducing live load daw, o pag ginamit mo daw tong formula na to na L na to para i-reduce yung live load, dapat pag chinek mo kung ilang percent yung binaba, dapat more than 50% yung na-exceed niya, no? So, dapat more than 50% yung magiging value nung makukuha mo. So, halimbawa dito, well, may nakuha kang ang live load mo dun sa mula dito sa table ay sabihin natin 100, okay? And then pag ano mo dito, na nakuha mong reduce na live load is sabihin natin 75. So, 75 divide mo doon sa original na 100, you have 75%. Okay? So, ibig sabihin greater than 50% siya, so pwede yung ginawa mong reduction. Okay? So, no reduction is also allowed kapag nag-exceed ng 100 PSF yung mismong load natin. So, dito, kung titingnan ninyo, ayan, may dalawang nag-exceed ng 100 PSF, no? So, yung light at saka heavy para sa warehouses kasi usually, yan nga yung may mga forklift saka may mga heavy equipment na dumadaan in between do sa structure natin, yung mga nagde-deliver. So, kaya medyo lumampas siya. So, pag lumampas daw siya, hindi siya pwede gamitin yung live load reduction natin. Okay? Kasi medyo critical yung structure na yan. And also, for public assembly, garages or roofs, hindi pwede yung ating reduction of loading. Okay? So, to illustrate itong paggamit itong formula na to, or yung pag-calculate ng live load sa given structure, I also have an example. Okay? So, bear with me. Okay? All right. So, example is two-story office building shown. Okay, this one has interior columns that are spaced 22 feet apart in two perpendicular directions. So, dito 22, dito 22. Okay, if the roof or yung flat roof loading is 20 PSF, again, pound per square feet, determine the reduced live load supported by a typical interior column located at the ground level. Okay? So we have a two-story. Then pinapahanap kung yung total na live load na isusupport nung mismong structure natin. Okay? So let's say i-drawing ko tong column na to in elevation. Okay? So pagpasensyahan nyo na lang yung drawing. Pero assume nyo na lang na maganda yung drawing. Okay? Ayan. Sabihin natin yan yung mismong column na yan. Okay? And then we have yung tributary niya. So ito yung portion na yun, no? So try natin i-drawing na lang na kunyari ito yung roofing, yung flat roof natin, and ito yung sa second floor natin. Okay? And then yung tributary natin ano na lang natin, no? Gayahin ko lang yung kulay. Yeah. So ito yung tributary area. Okay? So isin ko lang to. Ayan. So ito tawagin natin as yung roof level natin. And then itong portion na to is our second floor. Okay. So of course, this one will be our uh, GFL, no, or ground floor level. Okay. So given sa structure, 22 feet apart. So 22, ibig sabihin 22 to, no? 22 feet. Okay. And then di naman binigay yung height. So hindi naman natin concern yung height. And then we have a loading daw dun sa mismong roofing natin at 20 pound per square feet. So may loading na agad siya. So anong una natin gagawin? So i-calculate muna natin yung tributary area natin. Okay? So ibig sabihin itong figure na to, yung tributary na to. So basic area lang naman ng square. So 22 feet times 22 feet. So we have ilan? We have 484.0 feet square. Okay? And then we have yung influence area natin. Okay? Yung influence area natin is KLL times 80. Okay? So yung KLL natin is again, pag interior column tayo ay 4 times natin ng 484. Okay? Pag minultiply natin, that is equal to 1936 feet square. Okay? Na dapat, sabi dito sa code, balikan lang natin, dapat siya ay more than 400 square feet. And nakuha natin na value is way, way, way more than 400 square feet. Therefore, reduction of live load is allowed. Okay? Next, kunin natin yung load sa roofing. Yung kine-carry mula sa roof hanggang papunta sa ground. Okay? So, ilan yon? So, sabi sa kanina, sa example, meron daw tayong, ganyan ko na lang isulat yung loading, no? So, meron daw tayong 20 pound per feet square. Okay? No. So, lagay ko na lang, ano bang magandang ano? So, lagay ko na lang P roof. Okay? As loading, no? So, yung P roof natin will be 20 pound per square feet. And then, para makuha natin yung loading in pounds lang, kasi load yung pinag-uusapan natin. So, dapat sa area lang tayo, yung tributary area natin. So, times mo lang ng 484.0 feet square. Okay? So, 20 times 484. So, we have 9,680 pounds. Okay? Pero ang problema, si roof, hindi siya live load sa floor level. Kaya, hindi natin siya kailangang i-reduce. Okay? Hindi natin i-reduce yan. Kasi hindi siya floor load. Floor load lang yung nire-reduce natin. Or yung values taken from the table. So, saan manggagaling yung reduce natin? Yung reduce nating load will be taken from the second floor. And anong makukuha natin kay second floor? Ano yung P2F na lang natin. Okay? So, mapapansin natin, di ba sabi, office building tayo. Okay? And then tingnan natin yung table. Ano yung makikita natin doon sa table kanina? Occupancy or use. Ang gamit natin is for office building. Okay? And office tayo. Okay? So, nakalagay dito is 50. So, ito yung gagamitin natin. 50 PSF. Okay? 50 PSF siya. Ito yung unreduced pa. Okay? Pero since na-prove natin dito sa ano natin, dito sa portion na to, na reduction of LL is allowed, calculate natin yung value ng L. So, L is equals to L sub O, formula niya, okay, times 0.25 plus 15 over square root ng KLL 80. Okay? Substitute ko lang. So yung L sub O again yung nakuha natin sa table. So 50 times 0.25 plus 15 all over square root nung KLL natin. Na-calculate na naman natin kanina, no? Lalagay lang natin yung dito. Okay, so 1936. Ayan. So, kung calculate natin will be 50 times 0.25 plus 15 all over square root of 1936. So, makikipractice na lang pagpindot sa calculate. So, we have 29.545. Pwede na ba natin agad gamitin yon? We have to check or verify. Dapat i-check natin kung nag-greater than 50% siya. Okay? So, i-side checking na lang natin. Saan ba pwede ilagay? Ito na lang sa taas. So, 29,545 divide natin ng 50, yung original niya. Ang ilang percentage siya? So, that is equal to 59.09%. Okay? So, greater than 50 siya, 50%. So, ibig sabihin, pwede talaga yung reduction natin. Okay? So, itong na-calculate na to na value is in term ng pound. Yung unit niya kanina, PSF, no? So, same lang din. PSF pa din or pound per square feet. So, para makuha natin yung pound equivalent niya, katulad ng ginawa natin sa roofing, multiply lang natin ng tributary area na 484. Okay? So, pag kinalculate natin, 29.545 times 484, that will be 14,299.78 pounds. Okay? So, yung total load natin, P total natin will be equals to PR plus P2F. Okay? So, this will be 9,680 plus 14,299.78. That will be equals to 23,979.78 pounds. Okay? Or, pwede na siyang tawagin na 24,000 pounds. Or pag i-divide ulit natin, again, 1,000 pounds is equals to 1 kip. So, pwede yung sagot natin will be equals to 24 kips. Okay? 24 kips na lang. Okay? So, this will be your final answer for this example. Okay? So, ayan. So, yan yung para sa live load. Okay, next. We have yung sa environmental loads natin. So, for this case, we will no longer have an example kasi medyo mahaba na yung explanation nito and I know hindi na siya ma-appreciate kasi mas concerned na to ng structural engineer natin. Okay? So, two of the most common environmental loads that a structure may experience are wind loads and earthquake loads. So, define lang natin dito. Si wind load is produced by the flow of wind around the structure. And then, the magnitude of the wind loads that may act on a structure depend doon sa geographical location niya. So, kung yung location ng structure natin is wala masyadong obstruction, syempre, mas exposed na siya sa wind. Ngayon, kung madami naman siyang kalapit na mas mataas na structure, maliit lang yung chance na magkameron siya ng wind dun sa sides niya. So, yung sa roofing na lang niya yung medyo critical. Okay? Kasi pag tayo ng wind, merong tinatawag na direct pressure, meron tayong suction pressure, then meron tayong mga side pressure na nagaganap sa kanya. Okay? And this loads causes vibration dun sa mismong structure natin na eventually nag-i-induce ng mga forces dun sa structure na nakadagdag dun sa calculation natin. Okay? And then we have yung earthquake load natin. So earthquake loads is a horizontal component of the ground motion that causes structural damage and must be considered in the design of structures located in earthquake-prone areas, no? Especially dito sa parting Luzon, medyo madaming fault lines, no? Kaya lagi dapat as much as possible, kino-consider sa earthquake dun sa design natin. Okay? Um, yung sa earthquake naman, nakadepend siya usually sa bigat ng structure. So, mas mabigat ang structure, mas malaki yung earthquake forces natin. Kasi ang nangyayari dyan, meron tayong tinatawag na overturning moment. So, yung moment na yun is dependent kung gaano kabigat din yun. Kasi nga, di ba kung, halimbawa, ito yung structure, no? Pag lumindol, pag masyadong rigid yung structure mo, ganyan yung ano niya, force niya. Kumaga masyado siyang pigil na pigil doon sa paggalaw. So nangyayari, nagkakameron ng forces na mas malaki na nag-aak sa kanya. Then pag flexible naman tayo, o yung flexible, yung pag-move na iiwan yung ano. So pag flexible siya, so dapat ductile naman o kayang sumunod sa flexibility yung mismong design ng structure natin. So this portion is not covered na of our um, course today, pero gusto ko lang malaman yun na this environmental loads are also crucial when we try to design yung structure natin. Okay? So I think this is the end of our discussion. So if you have any question or clarification regarding what have been discussed, please don't hesitate to message me dun sa GC natin, and then I would gladly answer your questions. Okay? So if you have also the time, you can also click subscribe dun sa uh, YouTube account ni sir. Maybe you will encounter maybe some video na magiging useful sa inyo in the future. So please check it out. So see you guys next week for our next meeting, and thank you for watching this video.